No.
Or you try finding the next class.
Or you can try finding your next class. I think you'll find it just fine. You have a map. So what I did was I brought some cards, and I figured we could do a quick review of 243. Okay, get the balls turning.
I know.
The old probabilistic mind thinking again. This will get you prepped for the remainder of the term. So, deck of cards, poker cards. Tell me all about them.
There's 52.
52 of them. Poker deck, 52.
Fours.
There are red and black ones. How many of each? Four suits.
Two black, two red.
Two black, two red.
Then there's, yeah, ace through.
Yeah, 4 times 13, 52. That makes sense. So you got ace through king of each suit. So you got clubs and spades, those are the black suits, and then you've got diamonds and hearts, those are the red ones.
Yep.
Good. And I heard that there was half red, half black. So the chance of pulling a red card or a black card out of the deck is going to be 50-50. I said shuffling. Sorry. I'm very good at this.
Oh,
Sorry, I'm not very good at it. So if I go to Michael, grab a card, any card, and he, go ahead. I can't really read your mind. I'm not gonna be able to. I'd love to light them. What'd you get? What did Michael get? Well, the chance of him getting anything is a half, yes? So the chance of him getting a diamond is 1 in 4, but the chance of him getting a red card is 1 in 2. Everybody catch that? Was that a fair assessment I just made?
Yeah.
Okay. Michael got. He's not showing it for some reason. He got 6 of clubs. So the chance of him getting clubs is 1 in 4, and the chance of him getting black card would be 1 in 2. So that's good. Let's break that down just to kind of put the symbols. We'll get some symbols going from the olden days. So the probability of a black card is 1 in 2, which is also the same as the probability of a red card. What does it mean when I say the probability of a black card is 1 in 2?
Probability that any randomly chosen card would be black.
Is 1 in 2.
Yeah.
Good. Explain the 1 in 2 to me a little bit more. I love that, Christina. Thank you.
Roughly, when you pull an infinite number of cards, about half the time you will get a red one.
It's fantastic. You pull an infinite number of cards. Let's get on it. No, but that's exactly right, Lauren. The idea of 1 in 2 is a long-run probability, isn't it? It does not mean that every 2 times I pull a card, one of the 2 times I'll get a black card and one of the 2 times I'll get a red card. It means over time, I'm going to expect to get half the time black cards and half the time red cards, but it doesn't guarantee me when they're going to come. It just guarantees me that eventually I'll see half black and half red.
Or you have a messed up deck.
Or a messed up deck, which is good, that's possible too, right? But so it gives you kind of an expectation. You expect it. Good. Let's do it again. Another beautiful shovel. Tell me your name again. Deanne, you're going next. What's she going to grab?
Red card.
She got to just get a red. Because you're ignoring everything I just said.
Random events cluster.
Random events cluster, yes.
And spades.
So, Deanne, what'd you get? 3 of clubs.
Which the odds of that happening will
And the
be
same
I was
suit.
gonna say,
Now, hang on now. Let's go to that, Lauren. No, go. The odds of that pulling 2 clubs in a row.
is less than
1/4 square.
So, a tad unexpected, right? Go ahead.
okay, hang on. Let me formulate a thought.
Formulate that thought. Go. So, I'm talking about the suit or the color, Lauren?
The suit.
The suit. So, what's the chance? Let's go with the chance the first card is a club. We know that's 1/4, yes?
Yep.
But Lauren's talking about a very interesting point, which what's the chance the first and the second card are both clubs? Go ahead, Lauren. Get that thought
Is it
going.
big where you like put it back in so you
Right,
can
is it
draw?
with or
I put it back. You saw me put it back in, yes? Good. It's with replacement. I made that nice because it makes the math easier that way. Thank you. Very good question because it changes
No,
if you
she
don't.
was right. It is 1/4 square. Or
Yeah,
1
1/16.
squared over.
1/16, yes?
Yes.
Because the chance of the first one happening is 1/4. The chance of the next one happening is also 1/4, which means there's a 1 in 16 chance of it happening. Does that make sense? Is that fair? Okay? Was anybody kind of like, wait a minute, that's ridiculous. She shouldn't have gotten 2 clubs in a row. Well, that's okay, because what's this getting fairly close to? There was a percent. What is that as a percent? It's getting close to that magical 5%. It's a little bit above.
Yeah.
1/20th would be 5%. 1/16th a little bit bigger than that. But you're getting close to that. So if anybody was feeling kind of weird that she drew 2 clubs, yeah, it's maybe that's why. Maybe that's why, because she pulled two a fairly unusual, but not a ridiculously unusual event. I mean, it's kind of like playing poker and getting two clubs drawn or dealt to you. So you're working on a flush, essentially. All right. Shuffle them down. Ready, Skylar? You're next. Nice random selection of people in front of the room. All right. What's Skylar gonna pull?
Well, I want her to
What's you want her to pull on the club?
Don't say. But black.
Lemmy from Motorhead would be very proud. Ace of Spades. Say that again, Kate.
Put another black.
But a black card. Interesting. Interesting.
Did you prove to us that there's red cards in there?
Did I prove to you that there are red cards in here?
Oh yeah.
I don't know, what did I
all
prove?
have been
You just
black.
you didn't
I didn't
show us.
Hang on.
Oh,
We need a fresh seal, please.
You did.
I only brought one deck of cards.
Normal poker set.
Are you sure your son didn't tell us?
I asked you guys to describe the cards to me.
But you didn't.
Didn't I?
prove to us.
But you didn't show us it.
Watch, I'm gonna grab her red card.
Nope.
Whoa!
Working on a flush still, yes. Wait, why is everybody getting so pissed off all of a sudden?
Why is there red cards in there?
Some pissy attitudes all of a sudden in this classroom.
Because you didn't prove to us.
Because now we have an anomaly, Lauren. Let me swing this
3
camera
out
over
of
here.
4 clubs.
3 out of 4 club. Oh goodness. Well, let's. You know what?
And 4 out of
Oh, hang on. I like this very much. So. I didn't make you pull it, did I, Lauren?
Are they all black?
You still haven't proved to us that they're red
Because
cards.
what is this?
Random.
It's a deck of cards.
Use terminology from 240. It's a deck of cards, but you'll never know what's in it because it's your what?
Population. So
Boom!
your
It's your
sample.
population. You never get to look at your population. All you get to do is do a
Another club.
random sample from your population.
So it's skewed. It has to be completely skewed.
Why? Does it?
If we decide that that's a normal deck of cards.
Mm-hmm.
You
So,
left it on the board.
I left it on the board. Thank you. Here it is. Did you hear what Lauren just said?
No.
Say it again, Lauren. Nice and loud. That was beautiful.
I got another club.
Mm-hmm.
I don't know which card. Oh, if we assume that it's a normal deck of cards, we have a skewed block or skewed data.
Okay. So, when we started that little experiment, I held the deck of cards up. Did anybody go, ha, you bastard? No. I said, what's up with this deck of cards? And you said, well, it's 52 cards. They're half red, they're half black.
You
You
said it was
got
a standard poker deck.
You did.
You did. You did.
Say that again?
You said it was a standard poker deck, which therefore would mean
I
that
don't believe that.
you
Rewind the
did.
tape. Rewind the tape.
Totally did.
You were
The evidence.
Hi, Cora. Now, that was the assumption at the beginning.
You told us.
But now, all of a sudden, after the
That's your
third and
story,
fourth
you're
pull,
sticking to
what
it.
happened to this assumption?
We thought
You
that.
It
lied.
changed.
New possible belief, huh? I lied. New possible belief is that the deck is skewed somehow.
Did you
Now-
I don't think it's somehow. I think it's.
I think
We
it's
can tell you how it's skewed.
Yeah.
No, well, you can't though with certainty. You can't with certainty, can you?
Or we just pulled an anomaly.
That's why you can't. Lauren just told us
Yeah.
why you can't prove the deck is skewed with certainty.
Because anomalies.
You've only drawn-
do
Because
happen.
anomalies happen. That's the definition of an anomaly. It's an unusual event that happens.
What, you put one red card in there?
No, the anomaly is assuming that the deck is fair.
Just pulled 4.
Couldn't we have just seen 5 pulls like we did?
Yeah.
Very little in there.
JC?
So remember when we flipped the coin?
Yeah, but it's essentially what we're doing right now.
Yeah.
Essentially, go.
Remember didn't we have like 6 or 7 heads in a row? So now we're just changing heads and tails to black and red. The red was
So, random things did not have clusters.
Hang on.
Wait, is there a red card in the deck? You never answered that.
You don't know it's a population? Go count the American public. We'll come back to that question. Hang on.
Then we need to draw some more cards.
Hang on. Well, it is. You could count this one. It'd be more of a census. But the idea is, in general, you can't count your population. This is just a representation of that. Hang on. JC, thank you for that question. Lauren, thank you for your analysis too.
It's a fake deck.
First day. Dramatic cards.
Yeah. Well, because there's
It's the
only,
rare vote.
Oh, Brandon, could you, if you don't mind?
we get 5 clubs, we're like,
Okay, so here, we'll just, we don't see anything right now. This is an Excel simulation of the experiment we just did. This is 200 cards. This is JC's referencing, if you didn't have me for 243, on the first day of class. On the very first day of class, I showed you some runs of coin flips, heads and tails, and I said spot the fake. And the fake was one that didn't have enough clumps of heads and tails together, which somebody brought up earlier, the clumpiness of randomness. Thank you for that, whoever brought that up, and I forgot who that was now. Kate, thank you. So if you look up here, this is 200 random cards drawn from a fair deck with replacement, D'Angelo, like you said. Notice there's clumps all over the place. There's a big clump of black cards in the middle there, there's some clumps of red up top, some clumps of red down low. If I press F9 again, I get a reshuffle of 200. If I press F9 again, I get a reshuffle. If I press F9 again, I get a reshuffle. Clumps all over the place. Yeah? Do you see any clumps of 5 black cards up there?
Yeah.
Clumps of 5 black cards up there?
Yes.
Clumps of 5 black cards up there? Clumps of 5, okay, you see my point. So, based on this, it seems to be that we shouldn't be upset at all that we saw 5 black cards come out of that deck. Because it's got to happen somewhere. To which you respond,
Not the first time.
why did it happen on the first 5 pulls? Look at the first 5. Look at the first 5. 5 black cards on the first 5? Now I'm defining first 5 friends to be just these guys right across here. Right? First 5?
Nope.
First 5?
Nope.
First 5?
Yeah.
Oh, red. But no 5 black, yes?
Which it doesn't make a difference.
That doesn't matter if we define red and black. But we're trying to look at, you're right, probabilistically it doesn't matter, does it? It doesn't matter probabilistically whether they're red or black. 5 red would be just as unusual as 5 black. But what you're noticing is, regardless of whether it's red or black we're interested in, how often do you get all of those first 5 to be the same color? Hardly ever. So my question is, can you quantify how weird it was to see that? Can you give me a number to tell me how weird it was to actually see our result right here?
To the 5th, what?
Yeah.
Did everybody catch this over here?
864.
The question was, the answer was 1/2 to the 5th power. The chance that the first card was black, and the second card was black, and the third card was black, and the fourth card was black, and the 5th card was black, would be 1/2 to the 5th power. You guys did a small version of this problem over here, didn't you? What's the chance they were first and second clubs? You did 1/4 squared, which is 1/16. Well, 1/4 was because we were looking at suit, not color. If you're looking at color, not suit, it's 1/2. Renee, give me that question.
But doesn't it depend on how many times you randomize it?
Well, wait, doesn't what depend on how many times? The 1/2 to the 5th?
Yeah.
Thank you, yes. The 1/2 to the 5th only analyzes these 5 spots, not the other 200. The reason I put the 200 up there, thank you JC for asking first of all, but the reason is it makes you second guess the oddness of what we saw because you're like, oh, it should have happened somewhere. Yes, it should have happened somewhere, but we're not analyzing this entire thing. We're only analyzing the first 5. So let's come back to that, if you don't mind. Thank you. Because I have an experiment set up for just the first 5 cards as well. So basically, the only data we have is a random sample of 5 cards drawn, and that all came up black. The chance that they're all black, assuming that's true, very nice. Assuming, damn, Jim Mawson is working out with my slippery fingers. The chance that they're all black, thank you. Assuming this is true, is 1/2 times 1/2 times 1/2. It gets less likely with each pull, yes? And it ends up being 1/32, which is, let's see, a quarter is 25%, 12.5%, 6%, like 3%-ish. I'm gonna call that 3%. That's pretty small. Yeah?
Yeah,
Ish.
it is 3. I'm with you.
Roughly 3%, please.
For us that were in the previous one, a different future, could
Yeah.
you tell me the name of that theory again? The exact name, I can't remember it right now. Because you've been talking about the rare event rule, and now we're moving into,
We're talking like 5 things at the same time.
yeah, exactly, yeah.
Which is the beauty of this. It is like 5 things. Well, A, it's the binomial distribution. confusion.
Okay, there's no.
It is the binomial because you either get a red card or a black card.
Right. Okay.
This is one piece of dist fill. If you guys use dist fill, this will be one piece of dist fill, which you'll see a graphic of in a second here.
Okay.
It's the multiplication rule. If
That's
you're
what
going,
I'm
I think it's that. It's the multiplication rule for independent events.
Okay.
I think that's the formal.
Yeah, so it's kind of, yeah, I'm trying to grasp it all.
Fairly certain.
But that would be assuming that we have a deck that is
Boom!
standard where the probability of pulling a block is 1/2.
So, what Kate's concern is, assuming the deck is fair, that's the only way this probability even makes sense, because the deck is fair. But there's such a small chance of it happening that it becomes an outlier, which means it's an anomaly. So either one of two things could have happened. We saw an anomaly, or the deck maybe is rigged. What's the chance the deck isn't fair? Careful.
Who knows? How much do we trust you?
Careful. No, mathematically, what's the chance the deck isn't fair? It is or it isn't. What's the chance of it being unfair? That is a question we will spend 10 weeks answering. Because you can't do it right now. You can't do it right now. There's no way of doing that. There's a reason we can say, assuming the deck is fair, what's the chance we saw our results? Well, it's 3%, because we knew the 1/2 was there. If you think the deck isn't fair, how is it not fair? Now, I heard a couple different explanations for this deck. JC, what's one of them? No, but how is it, how could this deck, sorry, that's kind of vulgar, I apologize. What's one way this deck couldn't be fair? They can only black cards. I heard Kate say, is there a red card in there?
You could put less.
Maybe there are too few red cards in there. You see, there's different ways for it not to be fair.
Are there even
And
52 cards there?
And define fair.
Or it could just.
here we go, this is the game mentality. See, there's all kinds of questions that need to be checked off before we can quantify how the deck is unfair and what's the likelihood of that. So we're not going to do that in general in this class. In general, what we do is we assume it is and try to disprove that it is.
A population.
Thank you, sister. Yes, exactly. You have what's called a null hypothesis.
Right, you have to tell them basically.
Exactly. You have a null hypothesis, which is the basis that the deck is fair, and then you show it's probably not indicative that the deck is fair based on the data.
Right.
So if the data says the deck most likely isn't fair,
Which would require more draws than 5.
well, yes, of course. And that goes back to the point, as Deanne pointed out, your population, if the population is only 52 cards, you can just count them all and look. Yes, of course, but that isn't the idea. The idea is that your population is too big to deal with. That's the whole point in most cases. Your population is too large to deal with. And that's why you draw a random sample, but that's why it's so important that your sample is drawn well. Because that's the only snapshot you have of your population, is that sample. If you get a crap sample, you can make a conclusion based on that crap sample, but it might be completely off base. Renee, go! Concern. I think.
Can you have too many outliers?
What is...
But how does that?
Remember our definitions of outliers?
Well, hang on. I love this. I love this. I love this.
Well, that means you might have two different things you're looking at.
Good, good,
Two
good.
different data sets.
This is...
Yeah.
Well, and we'll deal with that in this class, I promise you that. We'll deal with 2, 3, 4, 5, as many as we need. But what, I want to come back to the question. When you say too many outliers,
Well, is there, like, if you had too many clumpings?
ah,
And then they're not outliers.
this is a fantastic question, thank you. So, I took a CPR certification class. I swear to God, this ties back to your question. Last spring, took a CPR certification class, multiple choice exam at the end, 25 questions.
Yeah.
I got 100, please. But the point is 25, A, B, C, and D. I'm taking the exam, and the answers go A, B, B, A, B, B, C, 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 D, D. And I start smiling, and I start looking around and all the kids taking it. I'm in the class with you. And they're flipping out. They're looking around at each other like, oh my God. So, obviously, the students thought there were too many clumpings. So, we created a test in 244 to test the number of clumpings you should have in a 25-choice multiple question exam. And as it turns out, it was borderline. And you guys do the exact same test in this. I have the exact same data you guys will play with in this class. But yes, you can have too many clumpings. You can. What you're seeing here are random assignations of clumpings, although some of them will have too many clumpings, because that's the nature of outliers. But the beautiful thing about it is, and this is the gorgeous part about randomization, if you use the definition of 5%, I think that rare event rule you guys were talking about from Donna's class,
Yeah.
that rare event rule, that 5%, is right around the time the human mind starts going, ah, something's up. Did you guys notice how pissed off you got when the fourth person pulled the black card? Then you're like, ah! Because the fourth pull was right around 5%. It's almost like your mind processes that 5%. It's like, it's too weird now! And then Lauren pulled, it was like, that's just the nail in the coffin! But that's it. That's the beautiful part. It all ties back to that 5%, which we'll get. Thank you. That's a great question. And Christina, yes, there are tons of different ways to measure outliers, as Christina pointed out, yes? There's the interquartile range, there's the bell curve, there's the 5%. You'll notice they all devolve to the same kind of big idea in this class. I promise you that. Harrison, go.
I had a professor in Colorado do that, like a quarter A's, a quarter B's, a quarter C's, and a quarter D's.
Just to
mess everyone.
Just to mess
all
everybody.
like in a row, and we had kids like walking out of the class. I was freaking out.
Yeah.
Yeah.
Because we have a preconceived notion as what random looks like.
And he did it just because he's like, if you really know it, you'll stick with your answer.
You'll stick with your answers, you won't second guess yourself based on some preconceived notion. But the idea of clumping is tricky though. I never taught you guys in 243 how much clumping is too much clumping. It's because I knew we were going to deal with it in this class. And it's not crucially important, because it's the kind of thing you can do if you need to do it. I'm going to be working here forever, so you can always just call me too if you ever need to analyze that thing. But the idea is, we do deal with it in this class. Thank you for that question. Jack, please!
It's like that little distrust thing is kind of like at the beginning of the last 243 class, I believe.
Mm-hmm.
The Excel on the 6 dice.
The 6 dice.
And then rolling 1, 2, 3, 4, 5,
1, 2, 3, 4, 5, 6. That was kind of freaky, but guess what? As Lauren said so aptly earlier, if you pull infinite cards, you'll get half the time black, half the time red. If you roll infinite dice, somewhere in those rolls you'll get 1, 2, 3, 4, 5, 6. It just so happened that was the one that happened first. Just like we did get 5 black cards first up here occasionally, and 5 red cards. It does happen, but it only happens roughly 3% of the time. Yo, Jack, it's perfect. What you said is perfect. It just sometimes it does happen when you stop and look at it and go like, holy crap. Holy crap, I just witnessed an outlier. But the problem with outliers are you don't know if they're outliers or if they're indicative of some other data set that you weren't expecting. That's what this course aims to deal with. How to make that decision wisely based on quantification. Yes. More on that on Wednesday though, yes? Okay, good. Go have a good rest of your day. I kept you over a minute, I apologize. Thank you for your guys' input. It's wonderful as always.
So is the deck stacked?
You're never gonna know, it's population. Get out of here.
Someone's jumping. I broke mine.
I can take you. I can take you. I'm wily.
I don't want to be able jumping. He would just take off running. And he's like, oh,
Let's see, we got 1 and 6 to the 4th to the 3rd power. Oh wait, was it 3 roll the Yahtzees or